All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be continuing learning about the Transformers library, or more specifically, we are going to be um, going into the more practical side of the Transformers library. In the last stream, I was hold on, let me open that up so you guys can see it. Actually, it's already open. I need to look at the Tmux window on my side. Yeah, okay. So in the last stream, I was asking Gemini a couple of questions, and well, the last stream was supposed to be focused on the Transformers library, but unfortunately, I ended up getting a little distracted, and you know, we we shifted our research towards other stuff. Other Hugging Face focused, Hugging Face relevant, Hugging Face pertaining. I guess that makes more sense. Other stuff pertaining to the Hugging Face platform. We were still focusing our research or keeping our research within the Hugging Face platform itself, but rather than focusing on the HF Transformers library, we were instead focusing on HF spaces and how to go about setting things up. A little update on that. After yesterday's stream, I decided to actually set up a Hugging Face space and test out the large file thing. And it was interesting. So I was under the assumption that there would be like a different section for bigger files or whatever. I think technically there is. I don't know how to explain this. I think they do classify like files past a certain point as big files. I don't really know how that whole thing gets handled by Git, because from what I understand, for bigger for bigger files, they usually have something called Git LFS. I've rarely ever touched it, so I don't really know too much about it. I should do some research on that at some point. Well, anyways, when you go to the settings of a certain space that you've created, so the space that you create is it's essentially like creating a Git a GitHub repo. There's going to be a bunch of information that you want to enter. Additionally, because it's a space, you have a template that you can select, and in my case, I selected Docker Streamlit, so that it prepares a space for me with a Streamlit project already, instantiated, and the environment, the relevant environment and tools and stuff like that that's required. It'll set up all of that for you, and additionally, it gives you a nice little example page, so you don't have to like start from scratch. It's just like you can set up the Streamlit template, and you can see what the UI looks like. I'm fortunate enough that I have prior Streamlit knowledge, because in the past I did take the time to do research on Streamlit. I've actually used Streamlit for multiple things. I don't think I mentioned this yesterday. I have used Streamlit for multiple things. I've used Streamlit for, first of all, my virtual Stream Deck application, which I'm just remembering that I forgot to check if I ever uploaded that to GitHub. I should do that. I should note that down so I can do it later. But yeah, I used it for my Streamlit for my virtual Stream Deck application. I also used it to create a sort of um, sales related, sales and inventory related uh, data visualization or data analysis application for a family member's business. I mean, I set up, because I had the sales data. They had the sales data available. They also had the inventory data available. Basically, all of that is from the accounting app that they use. So it's more about what data you are able to export. And there's quite a lot of different types of data that can be exported if you just take the time to prepare the specific reports that they need to be exported in. So, anyways, I took like a massive chunk of their sales data, so I could create different types of visualizations. Different products, different customers, different the topmost products that a specific customer bought, and various things like that. Sorry, zoned out. Okay. Um, what was I saying? Yeah, I've used it for that purpose. I've used it for another purpose as well, which was sort of finance visualization, finance analysis related. That was a sort of personal side project. Overall, I have used Streamlit quite a bit, and so I have a bunch of experience with Streamlit, even though I haven't touched Streamlit in the past, I guess you can say year maybe, or past almost a year. I would say probably a year, but like almost a year. Well, year. Let's say year. In the past year, I haven't touched Streamlit, but because I have all this knowledge and experience of Streamlit, which my knowledge isn't really that deep in Streamlit, it's just that I have some work experience with it because I've built projects with it. So I have some amount of knowledge of Streamlit and I have some amount of experience in it. And all it takes now is for me to just quickly go over there, over some code examples to just refresh my memory, and it'll all come back to me. Why was I telling you guys this? I forgot why I was telling you this. Oh yeah, I kind of got sidetracked with talking about. So you select the template for your Hugging Face space, right? And then you can create your space and launch it. And there's a settings section. You open up the settings section, and in the settings you can go and see storage. I forgot what the setting is called exactly, but there is a storage section. There it mentions large file storage limit 1 GB. It would probably increase like if you're paying, right? But for free, you get up to 1 GB. And I tested this out. I created like a just a binary file with a bunch of FF bytes, and I made it 1 GB in size. So it's 1 GB worth of FF bytes, how many ever, millions that may be. Um, what was I saying? Yeah, I prepared this 1 GB file and just uploaded it to the space, and it didn't upload because it wasn't exactly 1 GB. It was 1000 and something something MB, because 1 GB is 1024 MB. It's not exactly 1 GB. And this might have been slightly more than that. I don't know if their system is looking for 1024 megabytes, or if it's looking for 1 gigabyte, like how it's reading the thing. Or, oh, sorry, I don't know if it's looking for, if it has a hard cap of 1000 megabytes or 1024 megabytes. Um, Regardless, because it didn't accept that, so I created another file which was only 950 MB, and this time it accepted it. So this is how I know that this is our limit, which is actually pretty amazing, because this makes it so what I could do is, since a lot of my VODs are actually like anywhere between 600 MB to 1 GB, depending on how long I've been streaming, of course. If I do my usual only like 1.5 hour stream, then it might be anywhere between 600 to 900 MB. But if I go more than that, then it could be a little more. So what I could do is, if the VOD ends up being more than what I can upload, I can either trim it or split it. If the VOD is long enough that I feel like trimming it would make me lose content, then I'll not I'll not trim it. I'll split it. But if the VOD is like, if it's like close to, so let's say if it's 1.1 GB, right? I need to get rid of 100 MB worth of stuff, or 1.05 GB. So I have to get rid of 50 MB worth of stuff. I can just trim off the end of the VOD. Give me a second here. I need to just set something up, and yeah, we're good. Right. So that's great. Now that we have that set up, I'm a little more confident about using Hugging Face Spaces to run this entire application that I'm trying to build. I'm not going to have to run it locally. For the time being, though, well, actually, not just for the time being, the development in general is going to be local. And for the time being, I'm going to be running it locally. But eventually, the running part is going to be, it's going to move um, to spaces. The development is still going to happen locally. It has to be locally because um, I need the IntelliSense, and not just IntelliSense. I need my development environment. There's a lot that comes. There's a lot that, like, I don't want to minimize it to just IntelliSense. There's a lot more than just that. Within my development environment, within NeoVim, I have a bunch of different tools that are useful for me, which I need. I can't just work with a bare bones text editor kind of situation. So I need my development environment when I'm building this app, and that also means that I need to run these models locally. The good news is I can give it a small input, so I can give it like a 5 minute segment of the stream, or a 10-minute segment of the stream, and have the model process that and create its various create that batch of output that it's going to create, and then that can go to the next stage, and then that can go to the next stage, and so on. Hopefully, it's not going to be super heavy. Hopefully, at the very least, I'm able to run the thing. Even if the model ends up being heavy, it's only going to be heavy on my system for a short period of time while I test this out. And then eventually I can, push all of this to the space and give it a much bigger input and get a nice big output from that. So what I'm the idea here is that I feed this application. I don't know if I should call this an app. Yeah, I don't know if I should call this an application or one big model, because this is like a collection of multiple models. Um, so let's just say application. So the idea is that this application is going to receive a video file as an input, and the final output of the application should be timestamps for clips. So I will then take that entire JSON block. It's gonna export um, the the start and end timestamps for each of the clips as one big JSON block. Like it'll be a list of all the start and end timestamps. Additionally, I could also get it to come up with a decent name for the clip based on what's going on in the clip. Actually, that's a good idea. No, no. Hold on, that's actually a great idea. That is a great idea. I'm glad that I thought about this, because yeah, that's gonna help. Oh no, hold on. I just realized this. It doesn't have to be in the file name alone. I could add another field in there, in the output. I mean, I could add another field in there. So you would have the start timestamp, that's one field. End timestamp is another field. A name for the clip is another field. And finally, we can have a description field, which gives a short one sentence description about what's going on in the clip. The clips are supposed to be like anywhere between 30 seconds and 3 minutes anyways. I'm not planning on going any longer than that. So the description can be like, what was I saying? The clips would be short enough that the description can be that short. Yeah, I'm glad that I thought about this. So anyways, the output of the program is going to be a list of such data structures. Each data structure containing, actually, well, the entire thing would be considered a data structure, but a list of such items, let's say. Or no, we can say a list of data structures. Yeah, because each row can be considered a data structure. And so each row contains a start timestamp, an end timestamp, a file name, and a video description, or let's say video name and a video description. Right? So there's going to be an entire list of such data structures, and this entire thing is going to be exported as JSON. So I'm going to get a big block of JSON, and I'm going to copy that from my browser and paste it into my local, into another script locally, where I will parse that block of JSON. And actually, no, did I say I'm going to paste it into a script? No, I'll paste it into a file from which I'm going to read using that parsing script. So I'm going to write a script that reads this file, parses that entire that entire big block of JSON into a list of those data structures. It deserializes it into a list of data structures, and then it uses something like FFmpeg to just slice the original VOD, or create slices out of the original VOD using the timestamps and the video name, and then our clips are ready. So the application is supposed to take a video input and give you a JSON output, and then you do something with that JSON locally. The whole idea is running this entire operation on the cloud instead of running it locally, but you can run it locally as well. So I want to design this in such a way that if need be, actually, I need to design this in a way that is that it can be tested locally. So it kind of has to, you know, I have to be able to test this thing locally. That being said, if anyone does have a beefy enough machine that they're able to run these models and, run them at a decent speed, a decent acceptable speed, then they should be able to run this script. The only caveat there is that I'm not going to be able to get rid of this two-step kind of process where you first use one Python script, which is what's going to take the video input and produce the JSON output. And actually, you're not even going to be calling the script. You're going to be launching the UI, because this is meant to be a Hugging Face space thing. Oh, you know what? I could create a version that doesn't use Streamlit, but then I feel like that's going to be more effort than it's worth. Yeah, I don't think I want to do that, because with Streamlit, it's super easy, right? Even locally, you can start up this. You don't start up anything. You just do Streamlit run app.py or main.py or whatever. I don't know. I think it's app.py. You do Streamlit run app.py, and as long as you, I was about to say, as long as you have your environment activated, it should work. But I think I remember it working without the environment being activated as well. I don't remember exactly, but yeah, okay. For the sake of being on the safe side, as long as you have your environment activated, you should be good. It's gonna Streamlit is gonna launch the server, and it's gonna use the code from your app.py to create that whole web page and all of the backend logic and all, and then it's gonna serve up the web page to you. So anywhere on your network, you should be able to access this web page. Um, so that's gonna be one. That's gonna be one step, right? We launch the Streamlit app, and we give it the video input. We get the we get the we get the JSON output, and then we store that JSON output into a file, and then we run the second step, which is the actual I don't want to call that the main clipper. Well, yeah, technically that would be called the clipper, right? Or we could call it the slicer. I think so, because I mean, give me a second. Yeah. So I mean, it's okay. We can look into the name later on. Video extractor. Let's say video extractor. Yeah, the second step is going to be basically video extraction based on the JSON output that has been produced. And this should, if this entire thing works out well, then this should be we should be able to get some clips out of this. Whether they'll be good clips or not, I don't know. We'll find out. But um, but yeah, they'll be clips. Something I could do. Something I could do is for the sake of being on the safe side, just so you know, the trimming of the clips isn't too close to where the content begins. I could tell Gemini to, leave, not Gemini. Oh, actually, I don't need to tell any of the models to do that. I could get the interesting portions and then just, purposely for a start timestamp, I can purposely start 5 seconds before the actual timestamp, and for the end timestamp, I can purposely end 5 seconds after the actual timestamp. But that is if I start to notice that the content is very close to the timestamps, like the trimming is very close to the trimming of the video ends up being very close to where the content is beginning and ending. Then I can do that. I can add a little bit of padding, because when I'm uploading these clips, for example, if I'm uploading it on TikTok, TikTok has an excellent video editor. It has a bunch of great, editing functionalities, and it definitely has a very basic functionality to trim the video. So you can like trim off sections of the video. You can split the video. There's a bunch of things that you can do. So before I upload the clip, I can just trim the thing, and at least that way I'll know that no part of the content is getting missed. Anyways, I'm making all these plans and stuff. I'm coming up with ideas and stuff. We're gonna have to see how this works out practically, because we still haven't checked out the other stages. Now, uh, yesterday I was asking Gemini for suggestions on models, lightweight models that I could use. And Gemini gave a couple of suggestions for different tasks, not just for LLM related stuff, which is great. So we have a couple of things that we can check out. Before going into this list, I wanted to, um, before going into this list, I wanted to ask another question, which is security related, because I was curious about, I mean, obviously the answer is yes. But I still wanted to ask the question. What I wanted to ask is, do we need to worry about security when we are using these models? And the answer is yes, we do need to worry. I more so wanted Gemini to tell me what sort of, um, first of all, what sort of risks there are, what sorts of risks there are. But I also wanted Gemini to mention what sort of guardrails have been put in place by Hugging Face. And so Gemini gave me this answer. Another reason why I was curious about this is because when I was running some of the models through um what do you call it? When I was running some of these models in the Kaggle through Kaggle notebooks, then I had noticed that some of them do actually want you to enable remote code execution and trust code, something like that. I forgot. Allow trusted code, allow custom code, something. I forgot what the flag is called. Trust remote code. There you go. Remote code execution is a different thing. But yeah, trust remote code. Basically, some of these models, they have custom scripts for various stages of the model, be it like instantiation or like initialization or configuration or anything else. They have custom Python scripts that have not been written by the Hugging Face Transformers developers themselves. They have been written by the developers of the model. So those scripts are going to be used if you allow uh, if you allow if you set trust remote code to true. Uh, I, I I had to do this in one of the models. It was asking actually if you want to trust the remote code, and then I think at that point I decided to set trust remote code to true. In this case, though, I need to, before I do something like this, I'm definitely going to need to do proper research on the model, because trust remote code basically means it's custom Python code, and if it's custom Python code, then it can be anything, right? That being said, if it's like a very widely used model and there's something malicious going on, then you can expect the community to call it out, because these things are usually open source. They're not closed source. I mean, some of them are, but in many of the cases, if the model is being uploaded to Hugging Face, a lot of times it's open source. So you probably would be able to see the custom code. I need to look into how you would go about looking at the custom code. I should set up one such scenario and then try to track down the custom code. That'll be a separate conversation to have with Gemini. But yeah, I should look into doing something like that. So this was Gemini mentioning the various methods. One is the trust remote code thing. So you might have custom code execution. Then there can be malicious binaries and pickle files, which that's around the same around the same concept, because the idea behind pickle in Python is to allow you to export um, the entirety of some executable code as one object, and then you can import that object um, into some other Python code and just run that. And that's literally executable code. It doesn't just export data; it exports the instructions. So like that code is going to be executed in its entirety as it is, and that you know that that poses a security risk. Obviously, if you're getting the pickle file from somebody that you don't know, then you don't know if it could contain some malicious code inside it. Then there was the idea behind data poisoning and model backdoors. I don't think it went into the concept of model backdoors, but it did go into the concept of data poisoning, where that's more during like train words. It's more during the training process than during the inference process. If the model itself is trained on bad data, then like That's a different story. That's basically this, like data poisoning. It's trained on bad data, and that gives you like a different kind of security risk. Then you have privacy leakage. This was basically it's saying that you could be in a situation where the model has learned the data so well that it kind of parrots the data to you. It essentially mimics or mirrors the data to you. So if there's some personal information in the data that was used for training, and the model decides to mirror that data in its entirety, then you might actually, or it might actually reveal the personal information. And finally, there was the resource exhaustion thing where it was like, okay, specifically crafted or maliciously crafted inputs or model code could be designed to consume excessive resources and stuff like that to basically crash the system. Then they said, okay, Hugging Face safeguards. I didn't finish reading this section, so actually, I didn't even start reading this section. I was still in the other section up here when I uh, got busy doing other stuff. So let's continue reading. Oh God, dude, well, no, this is. I was about to say, oh God, we are about to get distracted again, but no, this is this pertains to Hugging Face transformers. Okay, so wait, give me a second. Okay, what was I? Where was I? Here. Okay. Hugging Face safeguards. Trust remote code equals false by default. This is the most important safeguard. By default, transformers will not execute custom code. You must explicitly set trust remote code equals true. Then safe tensors preference. I just realized something. Holy shit. Since I woke up, which is a good few hours ago, I have not eaten anything. All I had was an energy drink, and I'm on another energy drink. Holy shit, that's crazy. I did put some food on the flame for cooking, which reminds me I do need to go and check on the food, make sure it doesn't burn. Because I'm slow cooking it, but then I don't want to leave it alone for too long because it might burn. Right, so I will be back. Give me a couple of minutes. Okay, holy shit. I don't know how long I was gone. Uh but yeah, I went and checked my food and we're still good because I'm cooking like a stew slash curry kind of thing. And usually I put some water in it and then let it just boil for a while, like let the entire stew boil for a while so the vegetables and spices and everything, it just kind of melts together and the vegetables also get softened up and stuff like that. And because of that, every now and then I have to go and check the water level to make sure it hasn't gone too low and it's not burning the dish. So, anyways, I decided to put some potatoes in it. And so I had to peel the potatoes and, wash them and cut them and put them in and stuff like that. So that's why it took a couple of extra minutes. Anyways, let's continue here. Oh, wait. Actually, give me a minute. Okay. All right. So, we were at safe tensors preference. So, safe tensors preference. Hugging Face actively promotes and supports the safe tensors format, which is much safer than Pickle for model weights. So these are two things I need to look into. Actually, there was one more I think that I needed to look into. So there was safe tensors and there was GGUF, GUF, and there was one more. I can't remember exactly what that was, or maybe I'm just remembering wrong. But these are definitely two um, formats that I need to look into much more. GUF seems to be more either LLM focused or transformers focused. I can't remember which one it was. But yeah, I need to study both of those formats as well. I actually did have another conversation open with Gemini on another machine regarding that. Okay, community reporting. Users can report suspicious models. Okay, cool. Then, trusted versus community models. Hugging Face highlights models from official organizations. Example, Hugging Face H4. H4. I didn't know that would also be a Hugging Face thing. Then, of course, Google, Meta Llama. I saw Facebook being mentioned as well, which uh, Meta is Facebook, but like I don't know if I don't know, like in terms of the user account name, would it be called Facebook or would it be called Meta? Um, or if there's like a separate Facebook AI, there's a Meta AI. I don't know. I'm gonna have to look into it. Words. I'm gonna have to look into it. I can also check if there's a way to find out if certain like users slash organizations are verified. Though I'd imagine if people are able to create organizations, there might be some level of verification involved already. I'm not sure. Maybe anyone can create an organ. I don't know. I'm gonna have to check on Hugging Face. Right. Um, Hugging Face highlights models from official organizations and verified users, making it easier to identify more trustworthy sources. Best practices for users: never use trust remote code equals true unless absolutely necessary and you trust the source. If a model requires trust remote code equals true to load, be extremely cautious. If you must use it, consider reviewing the code, clone the model repo, and manually inspect all the Python files for suspicious code before loading the model. And running in isolation, use a sandboxed environment like a Docker container or a dedicated virtual machine for running such models, to run such models, limiting potential damage. Dude, you know what? I feel like Docker is something I haven't spent too much time looking into. One is Docker, and the other is, I think it's called LXT, Linux something container, or I forgot exactly what that stands for. Hold on. LXT, LXT container. LXC, okay. Uh, it, an LXC or Linux container is an OS level virtualization technology that creates isolated Linux environments on a single host, sharing the host's kernel but having their own file system, processes, and network, making them lightweight alternatives to virtual machines for running apps without full OS overhead. LXC uses Linux kernel features like C groups and namespaces for efficiency, allowing multiple containers to run like separate systems, ideal for sandboxing or testing. Platforms like Proxmox, that's something I definitely need to look into because I've seen other people mentioning. This was on TikTok. I've seen other people uh, mentioning like their home lab setup, and Proxmox was definitely one of them. Within Proxmox, you are able to create and manage multiple LXC containers. Platforms like Proxmox make LXC easy to manage, offering VM-like experiences such as SSH package installs, etc., but much faster and lighter. Okay, then let me look up LXC container versus Docker. Because I remember Docker being slightly heavier or, well, Docker still runs within the OS. That's one important thing to keep in mind. With an LXC, you don't require a full-blown OS. It's running on top of a kernel. I believe the kernel is managed by Proxmox. So I think it's the Linux kernel, and then there's Proxmox running on top of that. And then Proxmox is what's managing the different LXCs, and each of them are able to interact with the kernel. Okay, Gemini says the main difference between LXC and Docker lies in their scope. LXC provides system level containers that act like lightweight virtual machines, while Docker provides application level containers focused on packaging and deploying single applications. That makes sense. Okay. That makes sense because I have seen plenty of apps where they recommend running the entire thing within a Docker container. So I guess I could look into both of them, to be honest. Yeah, I could look into both of them because both of these technologies seem incredibly useful. One of them is going to be useful for a home lab setup. I'm actually tempted to um, try and run Proxmox. I have to see what the situation is with like UI and stuff. Because like I wonder if I could, I don't know, just have like one LXC container that's just running Firefox. And through that, I'm able to, just watch Twitch and YouTube and Netflix and stuff like that. Like, imagine how lightweight that would be. Like, no OS at all. Anyways, um, carrying on. If you must use it, consider reviewing the code, running in isolation. Okay. Prioritize reputable sources. Whenever possible, use models uploaded by official organizations. That's actually what I was going to do. I was going to mention this at some point that I noticed a bunch of these models are made by Google and Facebook, and there's a couple others. Of course, Hugging Face makes their own as well. There are other, oh, there's Microsoft as well. There are other like reputable sources, reputable like model creation organizations and users, and I'm not sure what to call that. There are other reputable creators of models as well. So I can just stick to those. NVIDIA has a bunch of models on here as well. I've seen them. I think I've used some of them as well. I don't remember. Um, but yeah, I mean, in general, I think I would be doing research on the model creators and the model itself anyways, because I don't just blindly, start using a model. For example, with something like Kokoro TTS, I had to I had to do some research on it and see what the situation is with it. Is there a community built around it? And it turns out there's quite a bit of a community built around it because it's a really useful model. Um, and the creators are doing a great job. The community is doing a great job helping build up an entire like ecosystem around that model. But yeah, prefer safe tensors models. If a model is available in both safe tensors and PTH/PT formats, always choose the safe tensors version. Keep your libraries updated. Regularly update your transformers library and its dependencies to benefit from the latest security patches and improvements. Sanitize inputs and validate outputs, especially in production systems. Never directly feed untrusted user input into a model without sanitization. Validate the model's outputs for unexpected or harmful content, particularly for generative models. Okay, monitor your environment. Keep an eye on your resource usage, CPU, RAM, GPU, while loading when loading and running new models, especially from less trusted sources. By following these precautions, you can, okay, all right, great. Awesome. So we can go back up here and take a look at the models that were mentioned. Um, okay, so they have DistillBERT, a distilled version of BERT. I have to have a conversation about this with Gemini as well. So give me a second. I just want to open this thing up in like a different. Hold on. Hey, um I'm using HF transformers to use various models. Um, I've come across DistillBERT. I don't understand these terms. Uh, Distill, BERT, what's going on? So I know that BERT is an architecture, right? But that's about all that I know. Just like that, there's a couple of others as well. A lot of times when you see these models, you'll have the name of the architecture as part of the model name. Like Llama is a separate architecture. BERT is also a separate architecture. And there's a bunch of models that are based on the BERT architecture. And then you have the distill part. I haven't understood that. But I kind of also want Gemini to just give me a rundown of exactly what all of the terms mean. Okay, it's completely normal to feel a bit lost. The NLP world is full of alphabet soup names. Essentially, DistilBERT is the light or compressed version of the original BERT model. Here's a breakdown of what these terms actually mean and how they relate. BERT stands for bidirectional encoder representations from transformers. Transformers, a specific type of engine the model uses. It also not it also it allows the model to look at the words in a sentence at once. Look at all the words in the, holy shit, dude! I need to eat. My God. Okay. Um, it allows the model to look at all the words in a sentence at once rather than one by one. Okay. Bidirectional. Most older models read text like humans do, left to right. BERT reads the entire sentence in both directions simultaneously. This helps in under, it helps it this helps it understand that in the bank of the river and the bank account, the word bank has different meanings based on its neighbors. Okay. The problem, the original BERT is huge. It's 110 million plus parameters. It's slow to run on your laptop and takes up a lot of memory. What does distill mean? The distill in DistilBERT refers to knowledge distillation. Think of it like a teacher-student relationship. That's weird to say. Um, the teacher, BERT, a massive pre-trained model that knows a lot but is heavy and slow. Okay, the student, a much smaller model that tries to mimic the teacher's behavior. Instead of just learning from raw data, the student the student model watches how the teacher thinks, which is its output probabilities, and tries to copy those results. Because the student is smaller, it can learn everything. Oh, it can't learn. It can't learn everything, but it captures the most important, um, 95 to 97% of the knowledge. Okay, how does this work though? How does distilling actually happen? Okay, DistilBERT was created by the team at Hugging Face to solve the size problem. Here's how they compare. BERT is 110 plus 110 million plus parameters. DistilBERT is around 66 million parameters. So that's 40% smaller. The speed 60% faster. Performance 100%. Performance in DistilBERT, it retains 97% of BERT's accuracy. Okay, and then in terms of layers, BERT is 12 layers and DistilBERT is 6 layers. Why should you use it? If you are building an app that needs to run on a phone, a basic laptop, or a web server where you want to save memory, where you want to save money on hardware, DistilBERT is usually the better choice. You get nearly the same intelligence, but with much less lag. Summary: BERT is a giant, super smart original. BERT is the giant, super smart original. DistilBERT is its faster learner, younger, learner, young, faster, leaner, younger sibling that is almost as smart but much easier to work with. Okay, okay, but how exactly does a model get distilled? Give me a second here, just checking something. Okay, to understand how a model gets distilled, imagine a master chef that, again, with the analogies, training an apprentice. The goal isn't for the apprentice to memorize the recipe, but to learn the master's intuition. In technical terms, this is done through a process called knowledge distillation. Here's a step-by-step breakdown. Initializing the student. Dude, just give me the information. Enough with the analogies. First, you create a smaller version of the model. Um, for distilled BERT, the researchers took BERT and removed half of its layers, going from 12 layers down to 6, okay, to give the student a head start. Oh my God. They initialized its weights using the weights from the teacher's layers. Okay, all right. Oh, accidentally hit my pop filter. Okay, I think maybe the analogies are or the analogy is helping a little bit. Learning from dark knowledge. Wait, so they initialize using the weights from the teacher's layers. Okay, all right. So the layers that were removed, that's fine. But then the layers that you kept, you used the weights for those layers from the original model's weights. Okay. Then, when a standard model like BERT looks at a picture of a dog, wait, BERT BERT can also do like vision stuff. I thought it was mainly text based. Anyways, it doesn't just say dog 100%. It might say dog 90%, cat 9%, 1% toaster. Okay. The 9% for cat is what researchers call dark knowledge. It tells the student that even though this is a dog, it's more like a cat than it looks like a toaster. It's more like a cat. Oh, so yeah, okay, these are all probability. I forgot. Yeah, it's all probabilities. So it's giving you the highest probability for what it thinks the thing actually is, but there's a probability that it could be something else as well, and there's a very low probability that it's a toaster. All right. The temperature trick. To make these hidden relationships easier to see, we use a temperature parameter in the softmax function. Oh, okay. If temperature equals 1 normal, the dog probability is so high it drowns out everything else. If we raise temperature, the distribution softens, making the 9% for cat more prominent so the student can learn that specific similarity. Okay, all right. The triple loss function. During training, DistillBERT isn't just trying to get the right answer, it's trying to minimize three different types of errors at the same time: distillation loss, student loss, and cosine embedding loss. All right, distillation loss. The student compares its soft probabilities to the teacher's soft probabilities. Okay. It tries to match the teacher's thinking. Then student loss, which is masked language modeling. The student still looks at the original data and tries to predict the correct hidden words, just like regular BERT. Then cosine embedding loss. The student compares its internal vector representations, the hidden states, to the teacher's. It tries to ensure its internal map of language looks geometrically similar to the teacher's. All right. Oh, okay. That's the end. Okay. All right. This information helped, and now we know what distilled BERT is. Okay, so distilled BERT, a distilled version of BERT, significantly smaller and faster, while retaining most of BERT's performance. Um, Then there's Mini LM, another family of highly efficient models. There are several variants and even smaller ones, and even the smaller ones perform remarkably well. So there's one from Microsoft, which is interesting. For sentence embeddings, often used with sentence transformers library, but okay. All right. What would be the purpose of these models? So it says general purpose, right? These models are great for tasks like text classification, token classification, and sentence similarity. What is Distilbert doing exactly? Let me just look that up. Oh, you know what? Let's go back to that conversation. Okay, so let's wait. I messed up. Okay, so let's go back to um, using. Okay, no, not go back. Let's get into using the models. Um, I've noticed there's distill, but uncased, and cased. What does that mean? Also, what exactly does what exactly can distill but be used for? Can it have a regular convo with me, or is there a specific purpose for it? When you're browsing Hugging Face, you'll often see two main versions of these models. The difference is all about how they handle capitalization. Okay? Cased versus uncased. Uncased, the model converts everything to lowercase before processing. It treats apple, apple, and apple, so like it has like different um, cases shown. There's uppercase, lowercase, and completely uppercase. Um, it treats apple, apple, and apple as the exact same word, best for most general tasks like sentiment analysis or basic document classification. It's more robust because it doesn't get confused by someone forgetting to capitalize a word. Cased. The model preserves the original casing. It recognizes that apple in all lowercase is the fruit and apple with an uppercase at the beginning is the multi-billion dollar company. Okay. It recognizes that these two might be different things based on that capital letter. Best for named entity recognition, finding names, places, and brands, or part of speech tagging, where capitalization provides a huge clue about what a word is. Oh God, oh, are we dropping frames? We are dropping frames. We are dropping frames. Let's wait. Hopefully it stabilizes. Wait, let's let's close the application here. Reduce the load on my system so that the stream can come back on. Okay, so we're no longer in the reds. That's a good thing. Okay, I think we are good. Yeah, I think we are good. I don't know if we had like a disconnect protection thing pop up. I have no idea. Hopefully, we are fine. Anyways, yeah, continuing on. What what can you actually use it for? Distilbert is a discriminative model, meaning it is built to understand and categorize text rather than write it. Think of it as a world-class editor, not a creative writer. Common use cases: sentiment analysis, intent detection, question answering, giving the model a paragraph and asking it to highlight the specific sentence that answers a question, spam detection, filtering emails or comments. Okay. Can I have a regular conversation with it? No, not in the way ChatGPT does. If you try to chat with a base Distilbert model, it won't talk back. If you use its fill mask feature, it will just try to guess a missing word in a sentence. For example, input the capital of France uh, is Mask. Wait, give me a second. Okay. Um, right. Why distill? No, why? Distilbert is an encoder only model. It creates a mathematical map of a sentence you give it. To have a conversation, you need a decoder model like GPT-2 or Llama, which is designed to predict the next word in a sentence over and over again to write a response. Pro tip: if you want a distilled model that can chat, look for Distill GPT-2. It uses the same distillation trick we talked about, but it's applied to the GPT architecture instead of BERT. Okay, so I'm still a bit confused about how exactly I'm meant to be using this model. Um, I've kind of gotten an idea from the example that you gave, but I still don't fully understand all the capabilities of this model. Help me out here. Also, in the future, when I'm looking at such models on the hub, um, in order to understand what all is possible with them, where exactly should I be looking? Or is it more that XYZ model has ABC features and what you do with those capabilities is completely up to you? That's actually true. Like what you do with it is completely up to you. I don't know why I was asking that question. I think I'm just trying to get some extra information, like more examples of, what you can do with it. Because what I'm understanding here is that this model is meant to do some sort of classification. It's meant to give you probabilities. And that is why you are able to use it to fill in words or um, classify text, use it for like spam detection and stuff, because there's like probabilities involved in this. Okay, it can definitely feel like you're standing in front of a giant wall of tools without a manual. To use these models effectively, you have to shift your mindset from what can this model say to what can this model measure or label. Interesting. Okay, here's how you can actually read a model's capabilities on Hugging Face and what DistillBERT specifically brings to the table. Where to look on the Hugging Face Hub? When you open a model page like DistillBERT base uncased, I should have also asked about the base thing. Yeah, I should have asked for the base thing as well. What base does or what base means in this case. Base as opposed to what. Anyways, you aren't looking at one thing, you're looking at a base engine. To understand, oh, are they going to explain what base means? Okay, okay, all right, good. To understand what it can do, look for these three markers, the task tags, the metadata, at the very top of them. Okay, yeah, I've done this. Yeah, I've done this. The Hugging Face, I can probably show it here. Hold on. The Hugging Face website, it has a great the model hub. Let's say it has a great set of tools for searching. You can search based on the task that you want, based on tags, and based on a couple other things as well. I think frameworks are also involved. Um, Let me just zoom out so I can show you guys a good version of this. Well, okay, yeah, this is a decent version of it. Never mind. So this is wait, give me a second. My mouse is misbehaving a little. Okay, yeah, there you go. So here you have a good example. You have different tasks. There's 44 different tasks that you can select from, ranging from multimodal and computer vision to text-based stuff, audio stuff, even tabular stuff. Um, I've never looked into graph machine learning, so that should be interesting to check out whenever I do. Then you can also select which specific library you want supported. Oh, also we can select, I just noticed this. You can also select if it supports safe tensors, if it has like a safe tensors version of the weights. Um, and then other filters here as well. But the more important ones that I'm talking about are tasks. Though there was one more thing. I think was I confusing between um was I confusing between task and something else? Because I remember there's you have the task itself, what task it's meant to solve, but then there were also other tags. Maybe I was confusing that with something like the libraries or whatever. Anyways, you do have a decent set of filtering options with which you can. And I just noticed this parameter thing. I don't know when they added this. I don't know if it was there previously as well when I was looking, and I just never noticed it, or if there was, or if they added it recently or what. But this can definitely help because, for example, um, I would always be looking for like a smaller version of the model. In fact, I'd probably be looking for something lesser so I can actually run the models. Like if I'm running the model locally, for example, then I would be looking for, you know, oh, dude, I should look into sentence transformers. Because this does seem to be famous. Function gamma, function gemma. I'll look into this later on. But yeah, okay. The task tags at the very top of the model card, you'll see tags like text classification. Let's open up this and yep, there it is. So these are the tags. If it says fill mask, this is a raw base model. It's a brain that knows language but hasn't been trained, that hasn't been tra- but hasn't been trained for a specific job yet. If it says task classification, someone has already fine-tuned it, given it a specific job, like detecting spam or sentiment. Okay, that's what fill mask means. Okay. All right. Okay, that's interesting. Then the model name. So the name usually tells you the head attached to the model. Distilbert base uncased is just the brain. Distilbert base uncased fine-tuned SST to English. Um, this is the brain plus a sentiment analysis head. Then Distilbert cased distilled squad is the brain plus a question answering head. Okay, the widget, the playground. On the right side of the page, there is usually a hosted inference widget. You can type text in there to see what the model outputs. If the output is a score, it's a classifier. If it highlights a word in a paragraph, it's usually a question answering model. The specific purpose of Distilbert. Think of Distilbert as a Swiss Army knife for understanding, not a ghost writer. You use it when you need to extract meaning from text instantly. Okay. Sorry, for a second there, I was just trying to think of like, how would I be using this in my own. Man, there's so much to explore. There is so much to explore. I feel like I really need to go into that LLM course because there is, in NLP alone, there is a lot for me to explore here. There's obviously a lot to explore in computer vision and audio and stuff like that. But in NLP specifically, there's a lot for me to explore. I need to go through that LLM course. I also need to get back to the, holy shit, dude. We never moved forward with that AI agents course from Kaggle. That's just like sitting in limbo now. Holy shit, dude. I need to move forward with that as well because that's a separate thing, by the way. So the Gen AI course, I don't know if I would or would not get similar information in the LLM course that I was going to get in the Gen AI course. It's possible. Maybe I might get similar information. So what I would want to do is I would probably want to go through the LLM course first, learn everything in the LLM course, and then go through the curriculum of or the syllabus of um, the Gen AI course, the 5-day Gen AI course, and see what is being taught in that course. Once I look at the syllabus, because it's like, it's mentioned on the course page. Once I look at the syllabus, I'll know that, hey, these topics that are being taught here, have I been taught these topics already? And if the answer is yes for most of those topics, I guess I don't need to go through the Gen AI course then, because it's been a good like 1 or 2 years now. I'm like late for it. As sad as that is to admit, I'm late for that course. I don't want to be late for the AI agents course because this is like a emerging tech right now. It's still slowly developing tech, and it's very useful tech as well. And this is like separate from using models, from like building and using models. The AI agents thing is separate because AI agents will help you create agent, or well, learning about AI agents will help you to create agents that can do the same stuff, that can do these things that you are trying to get the models to do. As in, how do I say this? The models do their job, right? You can create agents that actually use those models. So then you can have these agents working together rather than you having to set up logic to, take the input from this model and feed it to that model, and um, take the input into this model, get the output from this model and feed it into that model, and so on and so forth. Um, I think I did a horrible job explaining that, but yeah. Anyways, dude, you know what? Okay, I'm looking at the time right now, and I think I should end because I need to go and set up my food. I'm also a little concerned because potatoes can burn a little easier. Even though I have kept the flame pretty low, I'm still a tiny bit concerned because there is yogurt and potatoes in that gravy. So I don't know how well it's how, because I have to keep stirring it every now and then. I have to stir it. That's the point. Um, just a second here. Oh, what just happened? Hold on, what just happened? Okay, there is somebody here. Okay, never mind. The person is not here. Well, they're there, but like their chat is um verified accounts only. Scraggly working till I can't. Okay, let's check this person out. Okay, this is an interesting name. So this person's name is Where's Your Dad? I think we're gonna go. I think we're gonna go hang out in this person's stream. Hopefully, we are able to drop a raid for them, and it's not. There's no settings preventing us from doing that. Yes, we are. We are good to go. So I'm gonna continue reading up on this, and eventually I will start using this model and start using transformers in general to use the various models. But reading about this has made it clear to me that I do need to um, get started with that LLM course. I should also go through the LLM course and see if it teaches us how to build transformer models, because it does go into the transformer architecture. I did notice that. I don't know to what extent it goes into the transformers architecture, but well, not transformers, the transformer architecture, because transformers would be the library. Anyways, I don't know to what extent it goes into the transformer architecture. I hope to a decent extent so we get a good understanding of the architecture. But yeah, yeah. Anyways, so that's gonna be it for today's stream. I'm happy that we are back on our streaming streak, streaming regularly, and hopefully it's gonna continue. We're gonna keep streaming regularly. Oh God, the raid timer. Okay, okay, yeah, yeah. So that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.